We would like to move to last keynote speech. Professor Kensuke FUKUSHI, Vice Director of Institute for the Future Initiatives, the University of Tokyo. Professor Fukushi is a professor and Vice Director of the Institute for Future Initiatives, the University of Tokyo. He is also an academic program officer at the United Nations University Institute for the Advanced Study of Sustainability. His research interests include environmental engineering, risk assessment, climate change effect, water resource, biological technology, membrane technology. His research projects cover the integrated climate assessment, risks, uncertainties, and society, establishment of research platform for developing models to predict future health risks posed by changes in climate, land use and population, development of international network for sustainability science, and on health risk assessment in urban area. His presentation is titled, Monitoring Wastewater, a Novel Environmental Infrastructure for Preventing Disease Outbreak in Urban Areas. Professor Fukushi, now the floor is yours.
Thank you, Chairperson. You're flattering me. And seems to be I have done a lot, which is not really true. Without delay, I would like to start my presentation. First of all, I'd like to thank everybody who have arranged this meeting under the extreme difficult situation under COVID-19 pandemic. And I really congratulate. We have 164 participants that I'm seeing in the in the list, which is a great success. And I'd like to do my best for my presentation. Yeah, we have in Asia. There's a lot of water environment. This is one example I have taken in the city of Jakarta several years ago, informal sector. However, this is kind of a very interesting figure, having a water and resident. However, this water is important for this resident because this is destination of the wastewater discharge. But on the other hand, this water itself is dead water, which has no value for very limited value as a water. We cannot utilize this water. No living creature surviving this water. However, this canal, this small creek, is functioning as a destination of the discharge of wastewater. This is flooding. We like water. We need to have water. It is a very precious material resources. However, too much water is a big problem. If you have too much water, we call this flooding or inundation, that people are always suffering from flooding. That is experienced in the various places in Asia, especially Asia monsoon area, including Japan. Vulnerability. This is again in a water and resident, human and water relationship. This is city of Manila, and again in the informal sector, non-engineered house. I took this picture when I had a climate change adaptation project about how vulnerable these people are. However, these non-engineered houses renewed every 7 years, so theoretically, it is adaptability is quite high. But anyway, these people is under extremely vulnerable condition from the viewpoint of the economy, from the viewpoint of the climate adaptation, and health-wise, this water underneath of these houses is not that super clean, and because it's a dropping of the wastewater from these houses, it's just directly discharged into the water body, and utilizing this water is having a high risk of infection of the undesirable diseases. This is a very I mean the relationship of the individual SDG goal for if in the city water people relationship. Actually, people, resident, and city and water has a very interlinked, interrelated each other for entire 17 goals of the SDGs. So when we work in water and city, health people is a neglected matter, and we have to work on not only environment but also the individual health issue. People, I think that most of Japanese people have seen this picture on Tokyo Metropolitan Government. There is a river of Tokyo in 1970s. I think it looks worse than that of most of their river situation. Jakarta must likely maybe similar to this, but there we don't really surprise that just 40 or 50 years ago, situation of the river in Tokyo is like this. This is another picture that is also in Tama. This is Tama River in 1970s. This form of the water comes from detergent emitted from the kitchen and the and laundry, and that significantly affect the environment of the water body in Tokyo. This is not single phenomenon in Tokyo. I lived in Sendai when I was a child, and that is quite a difficult situation even in Sendai. Hirose River, one of the cleanest river in Japan, but that is difficult at that time when I was an elementary school pupil. But you may be surprised. This is a situation of the Tama River of today. It's beautiful. Of course, the water is not really super clean, but it's satisfactory clean. The living creature, aquatic insect, aquatic animal live in this river, and people can go close to the water and have no risk or a smaller risk of infection. Zero risk is there. It's not very difficult to achieve. I borrowed this picture from my department. This created a little bit long time ago. This is water supply and sewage and total population figure of a city in Tokyo. The coverage of the sewage and water supply is almost 100%, and total population is already a bit saturated. So this water environment, I mean, the improvement has done by coverage of the especially sewage system. This is the current landscape with water in the city. I don't know this landscape is good or bad. We have to have another evaluation of the landscape. Yeah, I mean, there maybe Sujan want to change this Nihonbashi in the right bottom side. This is like a former Chinatown, it doesn't look good. Yeah, maybe we need your help to change this place in other like Chongecheon did. But anyway, then this is a figure of the how much water share in the river is a treated wastewater in the city of Tokyo, and most of places it's not small amount of the water is treated wastewater and then discharged to the river. If we don't have a wastewater treatment plan, this blue area in the pie chart is a raw sewage, which has like several hundred milligram per liter of BOD, and that will be sufficiently consume the oxygen, dissolved oxygen in the liver, in the water, and liver is going to be dead water. The first wastewater treatment plant, of Japan, is located in Tokyo, 1922 in the Mikawashima, which is still running. Of course, it's a different system. Now we have activated flood. This is the oxidation ditch, but situation of the things is although the process has been changed, but we clean up the wastewater by power. That means that we have to apply huge amount of energy that swallow almost 2% of the total electric demand of Japan society. On the other hand, this is I borrowed this from my previous project I was running at the United Nations University. The city of Jakarta, this is a future projection of flooding in 2030. Then in the future, Indonesia, especially in Jakarta area, is expected to have a increased amount of the increased area of the flooding, especially in the northern part of Jakarta. This is a Jakarta watershed. This is a projection of the water quality on the major river in Jakarta. Of course, projection of the water quality really depending on their economic situation and master plan implementation, especially for the sewage plant or sewage system development. However, we by considering the master plan of the city of Jakarta, as well as the current trend, we are expecting the increase of the BOD, biochemical exchange demand, most of the places here. So flooding is going to be increased. The water quality is going to be worse. This is a future projection that has done by the United Nations University IAS, that we have a water pollution is going to be worsened by 70.56%, and flood area is going to increase 16%, and infectious disease, this is only for norovirus, it's almost double the number. How to design the future water environment in Asian city? Wastewater treatment, of course, it is very we have a sophisticated sewer network system. However, many researchers say that amount of investment for this sewer type of the treatment is huge. I remember in the Great East Japan earthquake, one of the major wastewater treatment plant in Sendai has been damaged and completely damaged. It's not functioning. And then we built a new one just next to that plant. By the way, that plant cover around 0.7 million people population equivalent. And the cost of the re-establishment of that wastewater treatment plant itself is $600 million US. And as you know, the sewer piping network almost cost 4 times of that wastewater treatment plant. That means the huge amount of investment has to be done there. However, now we have a technology made that the small scale wastewater treatment is possible, and then centralized and decentralized good combination might be the future of the wastewater treatment. The recycle at the decentralized treatment system is kind of encouragement for the recycling wastewater. Otherwise, we have to pump the treated wastewater from the big centralized wastewater treatment plant to the upper flow place for the recycle and reuse. Water environment is optimize the quality of the life of the resident and tourist. What is the function of the water in the city? We don't drink that water. We don't really eat the water, fish or shrimp from the urban river. However, it has a huge benefit or a value as a landscaping, and we have a lot of fun living with the water. Design a landscape and other function. So we have to think about the multi-value of water in the city. Of course, minimizing the health risk is mandatory. The Asian city living with water, because we have most of the country having a several meter, 1 to 2 meter, sometimes 3 meter of the precipitation annually. So we have to live with water. A sustainable city with adequate, equitable, affordable access to the water and sanitation. This is a must. And resilient city for future climate and urbanization. We have worsened the environment by climate change, and urbanization is also changing the society and the living environment drastically in very short time. low carbon city, carbon neutral city or decarbonized city is a target of most of the municipal leaders and country as well, through the integrated water management innovation technology. Science knowledge is very important. Climate projection, we need science, and application of the decentralized wastewater treatment process, we need a science and engineering. We have to have science and we have to have engineering in order to design the city. I changed the subject a little bit. I think this is old kind of newspaper from the New York Times. People are monitoring wastewater. Wastewater, including the feces and urine, and feces is one of the best one is blood, but the blood is a bit difficult to correct. But next to blood, feces tells a lot about what's happening in the body. And then measuring or monitoring their sewage, that including significant amount of feces, is directly measuring the health status of the citizen in the city. New coronavirus is found in the feces. Of course, it is not really, I mean, a gastronomic disease. However, it's infected in the throat, but a small amount of the virus is passed through the stomach, and then it regrows in the small intestine. Utilizing wastewater to project the status of outbreak of the city is now getting people are working on it. However, the technology enumeration method is not really established. People may say the enumeration might be difficult or impossible. However, many people still working on that. Sampling of low wastewater is difficult sometimes. I'm sorry, this is a busy PowerPoint that I made, but I put everything in one place. We have to start from here. We received the report from the hospital or government about the outbreak of the people, the cases of infection. But on the same time, we can detect the virus in the wastewater. Actually, reporting of the infected people from the hospital, the government, it takes some time because there's an incubation time. People may feel bad. There is time to decide whether I go hospital or not. And reporting also need a measurement of the viruses will take like a couple of days, and then reporting is going to another day. So it's going to be like good 2 weeks. In the case of the norovirus, it's 2 weeks is actually lag between the infection and reporting to the central government. But if you detect in the virus in the sewage, we can detect like this. Japanese city is not that big, and water flow and that the sewage flow is not that slow. So in one day it comes to the wastewater treatment plant. But of course we can sample this in the intermediate place like a pumping station. So we know this infection, what is happening in the city, like a couple of weeks before it became obvious in the city. Then we can do something like this. We have enact a state of emergency slight a few days, 3 weeks earlier than before. Then we may be able to stop the outbreak of the infection in city before it's getting very serious. On the other hand, I showed you that the flooding is a major things, headache in the city in the developing country, and that also one of the major infectious route of the waterborne disease to the people in the city in the Asian developing country. So if we know this information and if we know this situation of the health situation in the city, we can combine this geographical image, climate projection simulation, and health risk. And then we may combine this, and we may be able to project the risk or potential risk of the infection to the city. And of course, if we correct the entire various situation of the cases in the city, then we can maybe be able to propose some good guideline or measurement guideline or the guideline to establish the city with their sewage monitoring system to some authority like a WHO or United Nations, this is WMO or local municipality. So monitoring wastewater is a very important. This could be, I believe, a new and mandatory asset for the city or the sewer system. So city has to have sewer system, centralized, decentralized, anyway, but this monitoring is going to be mandatory. This prevent outbreak of unknown or known diseases. And good things of this wastewater is privacy is secured. We cannot, by measuring, wastewater, I cannot identify the President Watanabe as infected or not. we cannot measure it. But this is very fair method. However, it's very quick. But challenges is the water recycle is getting a little bit difficult because we know there are some viruses or infectious disease, yet people are recycling water. Recycling water is giving us some higher risk. Decentralized water management, the problem is management. Because of decentralized, we have to have a very good management system, whether this system is functioning is properly or not. And taking sample also difficult. Data security help this, the wastewater quality information have a lot of privacy information. For example, one district I observed like marijuana or some drug. Then, of course, this is a criminal, but this also is a private information, privacy information. So we have to be very careful this data security. Yeah, finally, I'm sorry, I borrowed it from newspaper. We are very busy for climate and COVID-19 now, but we have an even bigger impact may come in the future, and climate change or biodiversity collapse, according to their Johan Rockström and Will Stephens planetary boundary. These are biodiversity or climate change is even bigger effect to our planet. But we are washing hands that it won't solve the problem. Thank you very much.
Thank you very much, Professor Fukushi. We received one question from the audience. So
yes.
Now I read. For Fukushi Sensei, interesting to see the use of sewage to check health risks through feces analysis. Is research being considered for this in Japan? Is it being undertaken in the US? This is the question.
Yeah, this is practice in many countries, France, Italy, Spain, United States, Canada, Japan. But we are Japanese researcher put in a little bit difficult situation because the number of infection is small. That means the concentration of viruses in the sewage is very low. So we cannot gain the cases. This morning we had a discussion with American researcher, but there we are kind of envy. Of course, I should not say like this. Their wastewater have a lot of viruses. Then development of their detection technology or method is much more advanced than Japanese researcher. This is a situation. However, this is worldwide attempt, and we share the information of how to detect it wisely and effectively worldwide. That is the situation. Thank you.
Thank you very much, Professor Fukushi. And also thank you for your cooperation for timekeeping.
Thank you.